When we left off on Wednesday, we had two different identities to get through yet. Remember that when you are verifying these trig identities, we already know what the answer is going to be. It is our job to work on only one side. I also want to make a comment that when you work on these, you're going to be working vertically. So in other words, do not write things horizontally. You are always working down. The format for these is very, 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 I guess, regimented. It is definitely you're working vertical. It is definitely you are working on one side and you never touch the other side. And that second side that you never touch, you're just going to rewrite it in every case directly below it. So, I mean, the procedure is definitely very crystal clear. Now, when we look at a situation like D, what I told you the other day is pick the side that looks the messiest. Now, if you had to look at D and make a thought on which side looked the messiest, which one would you think? Okay, most people are going to say the right side. They see cosine squared, they say secant minus tangent, and I totally agree with that, and I understand where that would come from. But I'm going to disagree with that, okay? And the reason I'm going to disagree with that is this. If you take a look at the right-hand side, in my numerator I have subtraction. So hopefully we would realize that I could break this apart. I could say something like secant over cosine squared minus tangent over cosine squared, and it would clean up pretty quickly, okay? But if I look at my left-hand side, notice that I have addition, but addition where? In the denominator. So on the left-hand side, I can't break that apart because my adding is in the denominator, which makes my left-hand side look uglier than my right-hand side by far. In addition, on the left-hand side, you'll notice that secant and sine are both raised to the first power. On my right-hand side, I do have some things squared, which are definitely nicer than, in a lot of cases, having things to the first power. Now, when I look at that left-hand side, I see secant over 1 plus sine, okay? Now, I know that my denominator is the issue. And if you remember, this is exactly the same as having a radical in the denominator and I in the denominator. We are going to use what is called the conjugate to work on this situation. So right now, in my denominator, I have 1 plus the sine of theta. What will the conjugate of that be? 1 minus the sine of theta. Good. So the 1 plus the sine of theta, I'm going to multiply my denominator by 1 and subtract the sine of theta. What I do to the denominator, I also need to do to the numerator. Now, equal to, my right-hand side is going to stay exactly the same. Secant of theta, subtract tangent of theta, all over cosine squared of theta. All right, now I've got a whole lot of foiling and distributing to do. So secant times 1 is going to be secant of theta. Subtract secant times the sine. Over in my denominator, I'm going to need to FOIL that. So first, 1 times 1 is 1. Plus outside 1 times negative sine is going to be negative sine. Plus inside sine times 1 is sine. Last, we've got positive sine times negative sine. So that's going to be negative sine squared of theta. Equal to, my right-hand side is just going to be brought down. Secant subtract tangent over cosine squared. Now, just a comment, some things that people do that end up in situations where they end up losing some points. So first of all, notice that my right-hand side is being brought down. Notice I'm only working on the left. Notice I am working vertically. But notice I'm putting my angle in, that theta in every single place that it needs to be. I don't just write secant. I write secant of my angle theta. Too many people skip the angle. Sine of what? It's sine of the angle theta. You need to make sure that your angles are in there in every case. Okay, now, is there anything you notice? Anything you notice? All right, bottom cleans up, absolutely. Negative sine and positive sine are going to cancel. They're conjugates. That is exactly what should happen. So in my numerator, I have secant theta minus secant sine. Over, in my denominator, I have 1 minus sine squared of theta. Equal to, on my right, I have secant of theta minus tangent of theta over cosine squared of theta. All right, now, As I'm looking ahead, I always want to look ahead. I feel like I'm sitting pretty. I've got this secant of theta that matches right now. I've got this secant of theta in the beginning that matches. I know I'm headed in the right direction. Yeah, here I have secant sine. Someday I want that to be tangent. Not looking so good. In the denominator, I have 1 minus sine squared. Someday I want it to be cosine squared. Any suggestions? 1 minus sine squared is cosine squared. Okay, so that means that secant of theta minus secant theta sine theta all over 1 minus sine squared is cosine squared. All right, bringing that left-hand side down. Secant minus tangent all over cosine squared. Perfect. All right, now this matches, this matches. The only piece that's got issues is this secant of sine. Somehow I need to get him to become tangent. All right, so I start thinking, what is secant? 1 over cosine. Okay, so we got secant minus 1 over cosine times sine all over cosine squared. All right, equals secant of theta minus tangent of theta all over cosine squared of theta. All right, are we getting anywhere? What's 1 over cosine times sine? I'm multiplying these. What is 1 over cosine times the sine? Sine over cosine. Okay, so secant. Secant minus 1 over cosine times sine is going to be sine over cosine of theta all over cosine squared of theta is equal to secant minus tangent all over cosine squared. All right, any thoughts? Absolutely. Sine over cosine is tangent, so the secant of theta minus sine over cosine is tangent of theta all over cosine squared of theta is equal to secant of theta subtract tangent of theta all over cosine squared of theta. When we have addition or subtraction in the denominator, one strategy that is smart to try, it's not that it's always going to work. Remember, there's no cookie cutter recipe for these. But one strategy to try is to multiply by the conjugate in the numerator and the denominator. A lot of times that will help you.
How do you find?
Well, if it's 1 plus the sine of theta, my conjugate changes the sign in the middle, so it's 1 minus the sine of theta. Questions with that? All right, let's take a look at E. Let's take a look at E. We've got sine squared of theta over cotangent of theta equals tangent of theta minus sine of theta cosine of theta. All right, any thoughts? Which side do you want to work on? Right? Okay, let's give it a shot. I'll be honest, when I did this one, I worked on the left. But let's give it a shot. You should be able to get there either way. If not, we'll go back and we'll try it starting over on the other side. Sine squared of theta over cotangent of theta is equal to tangent of theta minus the sine of theta cosine of theta. All right, so let's give it a try here. All right, if we are working on that right-hand side, if we think the right-hand side looks uglier, what is the first thing we're thinking we should do? Okay, tangent equals sine over cosine. I can live with that. So sine of theta over cosine of theta minus sine of theta cosine theta, and is equal, I'm bringing that left side down, sine squared of theta over cotangent of theta. All right, Karina, you got a thought on where we might want to go next?
I don't know.
All right. Someone help her. Any thoughts on what we might want to do next? Just a question. How many quantities do I have right now? 2. 2. Eventually I need what? 1. I need this stuff all to go together into one fraction. How would I make that happen? Common denominator. Very nice, Karina. What is my common denominator going to be? Cosine of theta. All right, so this is right now over 1, which means that I'm going to multiply my numerator and my denominator by the cosine of theta. All right, so sine of theta over cosine of theta is equal to subtract sine. Cosine times cosine is going to be cosine squared all over cosine is equal to my left side, which is sine squared of theta over cotangent of theta. All right. Now there's a common denominator, so I can put them together. So everything is over cosine of theta. In my numerator, I got sine of theta, subtract sine of theta, cosine squared of theta, equals sine squared of theta over cotangent. All right. All right. Looking at that right-hand side, are we seeing anything we think we can try? Once again, not a right way, not a wrong way. Anything we can try. Give me a suggestion. What are you thinking we should try on that right-hand side? Okay, first thing, I look at the numerator, I see cosine. Can I do anything with him? No. I mean, there's not much I can do with just a regular cosine. Little to nothing that I can do with a regular cosine. So I look up in my numerator and I see sine, subtract sine, cosine squared. When you look at this numerator, do you notice anything? Yeah, there's sine in both of them. There is a sine of theta in both of them. So I can factor that out. Thank you, Leslie. All right, so I can pull that sine of theta out in front. Now, when I pull the sine of theta out in front, what am I left with in that parentheses?
1 minus
Thank you. Very nice. Sine divided by sine is 1. Subtract sine of theta, cosine squared of theta divided by sine is going to be cosine squared of theta over cosine equals sine squared over cotangent of theta. All right. Taking a look. Trig sheet is your best friend. Any thoughts now?
1 minus cosine squared is sine squared.
Beautiful. I need a numerator of sine squared. My gosh, 1 minus cosine squared is sine squared. So I get sine times sine squared over cosine theta. Now I got a question, and this is going to be a little bit sneaky. You're kind of sneaking in this in the back door a little bit. But here's my question. Really, in the numerator of this fraction, I only want what to be there? Sine squared. Is it not true that when I divide by a fraction, I multiply by the reciprocal, correct? So like, for example, just off to the side here, if I took 1/5 and I divide by 2/3, I'm going to flip the bottom fraction over, and I'm going to multiply by 3/2, correct? Isn't it true that I should be able to do the reverse? If I take 1/5 and I multiply by 3/2, that should be divided by the reciprocal. When I divide by a fraction, I multiply by its reciprocal. So when I divide by a fraction, I divide by its reciprocal, okay? You gotta think a little bit outside the box. Now, right now, in my numerator, I am multiplying by sine. Is it not true then that I will divide cosine in the denominator by sine? Okay, let's walk through that a little bit slower. I know it's a little bit hard to see. Is it not true? Maybe what I should have done here, and I'm just going to build this in. So I got sine squared theta over cotangent of theta equal to, is it not true that this is like sine of theta over cosine of theta multiplied by sine squared of theta? Yes, no, maybe? Okay. So if I multiplied by that fraction, I can divide by its reciprocal. So that means that I should have sine squared divided by cosine over sine. Because if I multiply by the reciprocal, I'll get back right where I started. I'm doing exactly the reverse of what we are used to. Does that make sense? Are you sure? Equals sine squared over cotangent of theta. Anybody confused by that? If I multiplied by the reciprocal, I would get back to exactly where I started. Now, in my denominator, I have cosine of theta over sine of theta. Yeah, it's cotangent. They're not easy. They're not easy. Let's take a look at this one. We're going to work on the other side. Okay? So we're going to look at this one. Sometimes you can make a choice to work on either side. All right. So let's take a look at E. But let's approach it completely differently than we approached it the first time. So I'm back to my beginning. I'm back to sine squared of theta cotangent over cotangent of theta equals tangent of theta minus sine of theta cosine of theta. And I'm going to make a choice this time to work on the right-hand side. Okay. All right. Now, when I decide to look on the left side, I'm going to decide to work on the left side. Is there anything on that left-hand side that I see? Cotangent is cosine over sine. Is there anything else? It is 1 over tangent as well. Yep, that would be another substitution we could make. Sine squared is 1 minus cosine squared. Okay, so let's try some things here. All right. First of all, I'm going to see sine squared is 1 minus cosine squared over cotangent. Now I heard somebody say cosine over sine first, so let's go with cosine of theta over sine of theta first. Equals tangent of theta minus sine of theta cosine of theta. All right, so far so good. I am dividing by a fraction. What can I do? Multiply by its reciprocal, absolutely. So I have sine of theta over cosine of theta multiplied by the quantity of 1 minus cosine squared of theta is equal to that tangent of theta, subtract sine of theta, cosine of theta. Now what? Now what? As I'm looking ahead, as I'm looking to the right. Yeah, do I see any parentheses on the right? No. I don't see any parentheses on the right. So let's get rid of them on the left. I need to distribute. So we have sine over cosine times 1, so that's going to be sine of theta over cosine of theta. Subtract. I'm going to distribute again, so I have sine of theta over cosine of theta times cosine squared of theta. All right, equals tangent of theta. Subtract sine of theta, cosine of theta.
How did you get the second sine over cosine?
Here, I distributed sine of theta over cosine theta times 1, and then sine of theta over cosine theta times cosine squared. I'm distributing this to the first quantity, and then I'm distributing this to my second quantity. All right. Anybody see anything? Anybody see anything? Beautiful. Very nice, Sam. Look at this first sine over cosine. Someday I want it to become tangent. This first sine over cosine, someday I want it to become tangent. Well, sine divided by cosine is tangent. So I can say sine of theta divided by cosine of theta is tangent of theta. All right, minus sine of theta cosine over cosine of theta times cosine squared of theta. All right, anything else? Anything else? Beautiful. Look at, I've got a cosine in my denominator. Here, this is cosine squared really over 1. I have 2 cosines in the top. What happens with the 1 in the denominator? It cancels with a single 1 in the top. So my squared cancels with the single cosine in the bottom. So we have tangent of theta. Subtract, well, this is sine of theta times cosine of theta, which is exactly where I needed to get. Now, the reason I wanted you to see this method is sometimes it is possible to work it, a situation, in more than one way. But sometimes one method will be much more efficient than the other. I mean, you'll notice we have a whole lot more steps the first method we used than the second method we used. But there are many times where there are multiple ways to get the same ones accomplished. Any questions? Okay.